So today we're going to talk about area problems, okay? So here's two rules you really have to understand or remember. First, always add if you can, okay? You want to add these area problems if you can, okay? Sometimes people like to subtract. That's when you could do it, it's just you make silly mistakes when you do that. So always try to add if you can. Secondly, draw the picture, please. When you draw them, it's going to help you understand what they're talking about. Okay, so write that down. That's the most important thing that you want to remember. Whenever you do area problems, always add if you can, and then draw. Okay, so we're going to talk about first type of area problem. Type 1, area increased by x all around. So for example, let's say I have a rectangle, okay? So this is type 1 problem. Okay, type 1, all around, okay? What would this look like? I want you to all think about this and draw it. What do you think we mean by the area increased by x all around in this picture? Yes?
If like the area increases by the same amount on each side.
Each side, okay? So, go ahead, draw it. See if you can figure this out. What do you think? Go ahead and draw it, okay? So I want you to leave this drawing and then draw another one. Okay, see what it will look like. Okay, because if you don't understand this clearly, then we will not be able to do these problems correctly, okay? So, it's the first type, area increased by all around, okay? By x all around. All right, so who could describe for us what this might look like? Yeah, one person?
Oh.
Really? Okay, yeah, what do you think? What did you draw?
I'm not sure.
Huh?
But I think it's just like a square or like a rectangle.
Yeah?
But instead of 3 and 4, it's 3 plus x and 4 plus x.
Not quite. Okay, first of all, is this what you had in mind?
No.
No. Okay, so this is what we mean by when we say all around. And it's a good thing that we're going over this now, right? Because if you understand the way you said, right, then will you be able to get the right answer? No. So do you see what I mean by all around? Look, x, some of you just did it on one side, but look, top and bottom and left and right. This is what they mean by all around. Does that make sense?
Isn't that the same thing?
Not quite, because I'll show you why it's not the same. Very good, okay? So who could tell me then the width of this new, the bigger rectangle? Yes, sir? 4 plus 2x. How many people say 4 plus 2x? Raise your hand. That is correct. What about the length? Michael? Wait, that's the length. So 4 plus 2x is the length. Width, what will be the width? From left to right? 3 plus what? 2x. Do you see why it's 2x, not x? No? Okay, I want you to discuss with your group. If you don't see it, ask your group member. Why? You should be able to see why is this not just x, 2x here. Because if you just put x, this is how you're going to get it wrong. Okay, discuss. Okay, go ahead. Ask your group member. Okay, how many people are not still not convinced that this is 4 plus 2x for the length, 3 plus 2x for the width? Who's not convinced? Yes, Samuel, you're not convinced? Okay, Samuel, let's look at the width. That's how wide something is, right? So right now, we had 3 for my width, right? How long is it from here to here, Samuel? X. How long is it from here to here? Huh? Right. Isn't it both x? From here to here is x, right? From here to here is x also. Right? So how long is it from all the way out here to here? If this is 3 unit and from here to here is x, here to here is x, what's x plus 3 plus x? No, I'm talking about how wide something is, width. I'm talking about the width. Do you see that this is 3 units from side to side? How far am I from here to here to the edge of this red rectangle? How long is that? No, from here to here on the left. Do you see where I'm pointing? From right here to here, Samuel. How long is this? Yeah, how long is this? What's the whole thing then? If this is x, 3, x. When you add them all together, what do you get? I'm sorry? You get 3x? Really? Say it again. What's 2x? No, what's the whole thing? Not just 2x. 3 plus x plus x. Isn't that how you get 3 plus 2x? You're just not are you not still convinced? Convinced? Okay, Samuel, let me ask you this. Hold on. Okay, Samuel, what is, let's say this length is 3, okay? Let's say this length is x. How long is this whole thing? Are you sure? Okay, what about if this is x over here? What is that whole thing then? Is it still 3 plus x? What is it? Yeah, 3 plus x, right? What is that? Are you sure? This is 3 plus 2x? Okay, guess what the width is then of this rectangle? What is it? Good. Do you understand? Are you convinced now? Are you sure? Okay, then Samuel, if you're convinced, okay, well, if this is 4, that's my length, and this is x right here, and this is x, okay? How long is this whole thing from here to here? Thank you. 4 plus 2x. It's not 4 plus x, is it, Samuel? From here to here is 4 plus. Everybody okay with this?
Yeah.
Oops, let's say 4x. 4 plus 2x. Right, from here to here, Samuel, is what again? Are you okay with that?
Oh,
Question.
or, so if it was gonna be 3 plus x, it wouldn't be all around. It would be
Yeah, exactly. It's not all around. When if it's just 3 plus x, would it be all around that we increase this the size and length and width by? No. Are we okay? Guys, I'm glad you asked, Samuel, because I cannot tell you how many times on the test, when I say all around, people think of just adding only one side. That'll be wrong. Do you understand? When I say all around, you have to add, because you have left and right, you increase by left and right, and also top and bottom. Does that make sense, guys? Do you understand? People mess up because it's not because they don't know how to do the math, they misunderstand what they're talking about. Okay? Alright. There's actually another type 1 where it's all around. Hold on a second. Okay, let's see if you really understood this. Okay, so what if we said instead of area increased by x all around, what if I said area was decreased by x all around with that same picture? 3 by 4 rectangle. Okay, everybody try now. Draw what this will look like from the original and write down the dimension of the new rectangle that you will get. So what do you think we mean by area decreased by x all around? And I even highlighted it, that part. All around. Okay, I'll give you time. Go ahead, everybody think about this. So, how many people got this picture right here on the right side? So you again get a rectangle, don't you? Because you're going in, right, from top and bottom and from left and right. Yes? Any questions? All right, then let me ask, if this is the picture we get, can you tell me the new length and the new width of the smaller rectangle? How about Eunice? Can you give me width? How? 3 minus 2x. How many people agree with Eunice? Raise your hand. She said 3 minus 2x for the width of the new rectangle, the smaller one. How many people wrote down 3 minus x? Okay. Yeah, that's how. Do you see why it's not correct? Why not? Can you explain to us?
Because you're taking it from both sides.
You both sides. That's exactly. And how do we know that we're supposed to subtract from both sides? Because it said all around. Do you see the difference? So how many people? So here's the. It should be. This is the right way. You should have put down the width equals to 3 minus 2x, and then for the length 4 minus 2x, right?
Yeah.
Raise your hand if you got both of these right. For the first one, it is 4 plus 2x and 3. Okay, Jason, did you have a question? Thank you.
Yeah. How do you know which one is length and width?
Oh, width is how, okay, from side to side. Width, how wide something is wide. Think about wide with width. Okay, and then length is, but it really depends. Okay, does that make sense? Normally that's what they mean. But for a rectangle, it doesn't really matter because you could rotate them, but don't worry about it. Just width, think about width as wide and length as the other one. Yeah, any question? So this is type 1. Is this okay? Now can I talk about type 2 of these area problems?
yes.
Okay, all right, here we go. Here we go, guys. Write this down. Type 2. Area increase one side. Now we have area increase one side. Again, same rectangle, 3 by 4. Okay. It says the area increase one side. Okay. What would this be? By x, I mean. Increase one side by x. I should write that down. by x. Go ahead and draw the picture and see what you get. Okay. Be different. Right here. Area increase one side by x. Okay. Question? Which side? Okay. Well, think about that. Okay. Go ahead. Yeah. It doesn't really matter, but just one side. Okay.
Does that mean length? Or?
Yeah. Length and width.
Okay.
Yeah. One side of the length and width, okay? It's just one side of the length and width, okay? Okay, guys, listen. How many people got this picture? When I say one side of the rectangle, I mean the length of the... So this is what I mean, length and the width. This way, like this. Just one side. I mean length and the width of one side of it, okay?
That is so not. What is that? Oh wait, that is what I did. That is.
Okay, so, okay, I see. Okay, so if you... Okay, listen, that's correct. Guys, listen. One side of the length and the width of one. I don't know how to say it. Okay, anyway, I guess I could be talking about this too, depending on the question. If I just increase the width, but when I should have said then increasing length and width only. Is that okay? Length and width. How about that? Instead of saying one side, I see why you're getting confused. If I increase length and width, this is what I mean. Is that okay? So instead of saying one side, I should just write down length and width. Increase length and width. Is that okay? I didn't say all around, right? Do you see why this is different than the other? None of it, I didn't say anything about all around. I just said one side. I should have been more careful. I should have said the length and width are increased. Is that okay? Length and width. All right, so then what is going to be my new length and width? Go ahead, write it down. I'll wait. Here we go. Eric, what did you get for the width of this new rectangle, the bigger, of course, rectangle?
W equals 3 plus x.
3 plus x is correct. And the length is, of course, 4 plus x. Are we okay with this, guys? Do you see what we mean by the length and width are only increased? Not all around. Do you see how we get a different picture? Okay? Any question? Raise your hand.
No.
Okay? Alright, then, let's see if you really got this. Here, try this. I fixed this. Type 2. Length and width are increased by x. Okay? Oops, here. It's the same rectangle, 3 by 4. The length and width are increased by, decreased by x this time. Let's do decreased by x. So I changed the wording. So, yeah, the one side was not really good. Here. Length and width are decreased by x. What would this look like? And give me the dimension of the new rectangle that you get, okay? Go ahead, everybody try. Okay, Dakota, did you get this picture right here? Okay.
No.
No?
I did the other way, the opposite.
Okay, it doesn't matter. You could have gone from left, and it doesn't matter. But what's more important then is what is then your new width, Dakota? So you could have done it the other way on the left side. What is the width of this? It should be the same. Okay. 3 minus x. Is that okay, guys? What's the length, Eric?
4 minus x.
Yeah. So even if you did it on the other side, your picture may look a little bit different. Your area may look like an L. Is that what you have?
Yeah.
Yeah. So, but nevertheless, the length and width are the same dimension. Would you not agree?
For my way, what point does the arrow place? Does it go on the right side or the left side?
Yeah, it doesn't really matter as long as you go from only one. You know, length is decreased by 3, width is decreased by 2. Are we okay? Does this make sense? Okay. So, do you guys see the difference between type 1 and type 2?
Yeah.
Okay. All right. If you know that, let's then go to our. Let's do an example now. Is that okay? So this is really important that you understand the difference between type 1, where is this all around, right? Like this picture, right? And type 2, where is this picture? Whoops. Are we okay with this? All right. Here we go. Okay, guys, write this down. Equation of area problems are, write this down. This is fact, are always same. Or the formula, okay? So whenever you come up with an equation of the area problem, I should write down formula instead of equation. Can you write down formula? Sorry, let me fix that. Here you go. The formula is always same. Of course, at least the type that we'll be working on tonight, okay? It's always going to be this. Total area is equal to area 1 plus area 2. So write that down. And of course, if it happens to have, if the area is divided into 3 pieces, it'll be area 1 plus, area 2 plus, area 3. But the total area is going to be area 1 plus, area 2 plus. I mean, yeah, area 1 plus area 2. For at least this type of question that you will see. Yeah, question?
What do you mean by area 1?
Yeah. Let me give you an example. Okay. So at least for this type of area question, let me show it to you. Okay. First, write this down. I'll wait. So guys, remember this type of question? This picture was for both area increased by x or decreased by x, right? It looks the same, right? The one that decreased was, right? You had the original one, bigger one, but it doesn't matter. You get the same picture. What do you think then the formula for this is to find the area?
Oh.
Yeah.
It's the wait. I'm confused.
Look at the formula that I just gave you. Yeah, Aaron?
Area 1 plus
Exactly. So the total area is going to equal to, which is this, right? Isn't this my total area, the whole big rectangle? Right? Is equal to what, Aaron? Area 1? What do I mean by area 1? Yeah, the smaller rectangle plus what? The bigger rectangle? No, the bigger rectangle is the total area. The smaller rectangle plus, yes, Dana? The added side, which should be the increased area or the decreased area, depending on what kind of problems you have, right? Does that make sense? Isn't that how you find the total area? You find the smaller rectangle plus the area that was increased or decreased. Doesn't matter, right? It depends. Well, it does matter. It depends on what the question is, right? If the area was increased, then that's the increased area. If the area was decreased, that's the decreased area. Do you guys see that? Isn't that the total area? Total area is always that whole thing, right? The total area, the whole thing. That's why it's called total area. Would you not agree? So this doesn't matter whether or not you're doing the area was increased by x, right, or decreased by x. The total thing is, of course, equal to the rectangle plus, you could call it the frame or something, the frame. Right? That's the area that was increased or decreased. Correct? Is that okay? Does that make sense? All right. So what about for type 2 then? May I move down a little bit? Okay, let's look at type 2. So type 2, again, this is for either area increased by x, right? Or decreased by x. Doesn't matter. Don't we get this type? What is the total area going to be? Remember I told you the formula for these area problems is always same, correct? Total area is equal to what? The area 1, which is? What, class? Area 1 is the smaller rectangle plus what? What's area 2? That's the area that was increased or decreased by adding x or subtracting x. Does that make sense? The L shape. Well, this is not really L shape. For some of you, it's L, right? But it's the, you know what I'm talking about? This is the area that was either increased or decreased by, right? Depending on what sort of problems you get. Do you see? So remember, do you see how the formulas are all both same? The total area is equal to what? Area 1 plus? Area 2. What's area 2? That's the area increased or decreased. Does that make sense? Everybody okay with that? Is this pretty straightforward?
Yeah.
Okay, so noticing this will help you to figure out how to do these area problems. Of course, if you don't understand which type we're talking about, it could be very difficult. Yeah, question?
Wait, so our homework's gonna be to find the whole area of the whole thing?
Well, you'll find that. Let's do some examples then. Okay, so it'll be, of course, on your homework, they're going to give you some variations for these, but this is a general idea. Okay? Is this okay? Yes? All right, let's move. We'll do number 1 together. We'll do number 1 and 3, and if we have time, we'll do the other ones. Maybe not today, but tomorrow. Okay, so number 1, who would like to read number 1 for us? Go ahead, Jason.
Hector made a rectangular fish pond surrounded by a brick walkway 2 meters wide.
Mm-hmm.
He had enough bricks for the area of the walkway to be 76 meters squared.
Mm-hmm.
Find the dimensions of the pond if it is twice as long as it is wide.
Okay. Now, I want you to all think about this and show me with your fingers, is this type 1 or type 2? Type 1 is where you had the frame around it. Type 2 is where you had that L shape around it. Okay, show me with your finger, 1 or 2. I want 100% participation right now. Think about this. I'll give you more time if you really think about this. If you're done thinking, show me with your fingers whether it's type 1 or type 2. Hector made a rectangular fish pond surrounded by a brick walkway. Okay, not all of you are participating. Okay. Eunice, what did you come up with? Is this type 1 or 2? You are correct. It is type 1. This is where you have the
All the way.
the whole. All right. How did you know it was type 1? What gave it away? What gave it away, Eric?
It says twice. Oh wait.
No, that's not the part that.
Yeah, it's twice.
No, that's not the part that shows you why it's type 1 or type 2. Which part from the problem did you know that it was the one where you had the x increase all around, not just one side?
Surrounded by wood.
Surrounded by. Does that make sense, guys? If they didn't say that, you wouldn't know whether it's type 1 or type 2. Does that make sense? Right? It would not be clear, at least. So what I want you to do is, since it's a word problem, I want you to declare a variable. Read, of course, and then declare a variable. And do you think it's a good idea to draw what's happening? Go ahead and draw these two pictures, what you have before and after. Or I guess it is actually this one you can actually draw them all together, right? Go ahead and draw what they're describing, okay, with appropriate labels, okay? See how you could do that. Go ahead, I'll give you time. Of course, you could do this as a group if you get stuck, okay? I'll give you time. Okay, first of all, how many people got this? Declare a variable, let width to be the width of the pond, 2w be the length of the pond. Is that okay? Where did I get this from, guys?
The last sentence.
Last sentence. It says the dimension of the pond if it is twice as long as it's wide, which means whatever the width is, the length is twice as long. Correct? So that's your original rectangle. Are we increasing the area or decreasing the area? Increasing, because you're going to put a walkway around it. Right? Now go ahead and try to finish the picture. So you should have at least declared this variable like this correctly. Then see if you can figure out the picture and figure out the new length and width of this. Okay, go ahead. I'll wait. First of all, how many people got this picture right here? Okay. So you had the original W by 2W. Now you're increasing by 2 everywhere. How many people wrote down 2W plus 4, not 2W plus 2? How many people wrote down W plus 4, not W plus 2? Raise your hand if you got this. If you didn't, go ahead and fix it. Do you see why it's W plus 4, not W plus 2? You got to add left and right. It's all around it. That's why, do you see why drawing it really helps? Does that make sense? So here is your new width and here's your new length. Does that make sense? This was the length of the pond and the width of the pond. And now we have the length and the width of the whole thing, the one with the walkway all around. Does that make sense? So if you don't have this, go ahead and fix it. Did you get that? Okay? Alright. Alright, so now that we know we know what it looks like. We know the dimension of the pond and we know the dimension of the whole thing with the walkway. And we told you that the formula for area problem is always same, right? Lindsay, what did I tell you the formula for the area problem is?
Is the
What's the formula for these?
is the total area equals area 1 plus area 2?
Exactly. Total area is area 1 plus area 2. In this case, what's my area 2? The area that was increased or the area increased, which is this frame, this yellow frame. You see that? What's area 1, Claire, in this problem?
Area 1.
Uh-huh. Remember, total area is area 1 plus area 2. In this case, what's
Area 1 is W plus 2W. No,
times?
W times.
Okay, yeah. So what I meant by this is just in terms of picture, the total area, the whole thing, the whole red one is the smaller rectangle plus the frame. And you're right. That's how you find the smaller area, smaller rectangle. Now, here comes then the equation. Who could tell me? Remember, this formula is always same. Total area is smaller area plus the area increase or decrease. Yes?
So when it says find the dimensions, what do we have?
We're not done yet.
Oh.
Okay, what they mean by that is find the length and the width of the
Okay.
pond. So to find the length and the width of the pond, we need an equation. So from this formula, who could tell me what is then the total area? How do I find the total area? This big red total area. Yes?
The total area is 2W plus 2x times W plus 2x.
Well, it's not 2x anymore. My x is 2.
Oh.
So instead of 2, you should write 2w plus 4, right? Twice of this x is 4 now, right?
Yeah.
I'm not using x. So you're right. What's the area of the total area?
2W plus 4
4 times.
Times W plus 4.
Yeah, so I'm telling you what x is now, you see? Good. Is equal to, what is this area? Smaller one. Claire just told us. Dana?
76 plus W times.
No, I'm talking about this rectangle. What's the area of this rectangle?
Oh, the total.
No. Small, the black one. Inside the pond. The pond, the area of the pond. Isn't that the area 1? What is the area?
Times W.
Yeah, 2W times W. Now, what about the area of this area increase, which is the frame? Yeah.
76.
Where did you get 76 from? Yeah, they told us. Look, from the problem, didn't they say the area increase was what? We had enough bricks for the area of the walkway to be 76. Another way of saying it is that brick area, walkway area is 76, right? So all you have to do is what, guys? Write down the equation. There's your equation. You see how I have total area W plus 4 times 2W plus 4, right? Length times width, correct? Equals to the length times width of the smaller rectangle, 2W times W plus 76, which is the area of that walkway. Is that okay? Yes? I'll move it up for you. Okay, so of course when you multiply these binomials together, you gotta multiply the first term with the rest of them and then the second term with the rest of them, right? You guys remember that? Remember? You gotta multiply W times 2W times W plus W times 4, right? You guys remember how to multiply binomials together?
Yes.
And then 4 times 2W and then plus 4 times 4. So you should have gotten, when you add them together, how many people got 2W squared plus 12W plus 16 equals to 2W squared plus 76?
Wait, we're not supposed to solve for W?
We're not done yet.
Oh.
Okay. Then what do we do next, Michael?
We minus 2W squared.
Thank you. We're going to gather the like terms. Let's do the one with the highest exponents first. So I'm going to subtract 2W squares together. And good thing happens because they cancel out. This is good because we don't know how to solve equations with something squares yet. Okay, we're going to learn them later. But for now, since we don't know, they're not going to give you one with W squared or something squared. Okay, then, of course, we're going to subtract 16 from both sides, correct? And when I do, I get 2W equals to 60, don't I? Of course, all we have to do is divide both sides by 12. The answer is, how many got 5? Raise your hand. Okay, they asked for the dimension. What do they mean by dimensions? Yes. The length and the width. We only have width. How do I find the length?
Times
Yes.
Multiply by 2.
You multiply by 2 because they told us in the very beginning, remember the pond, the width and the length, right? The length was twice as much as the width. So you multiply that by 2. Here the answer. Of course, you got to write it as a sentence, right? The dimensions of the pond are 5 meters by 10 meters. Okay. Any questions? Who could read example 3 for us? Somebody that didn't go today. How about, yes, somebody that I have in there. What do you think?
A rectangle is twice as long as its width as it is wide.
Mm-hmm.
If its length is decreased by 4 and its width is decreased by 2, its area is decreased by 24.
Mm-hmm.
Find its original dimension.
Good. Now, before you do this problem, you should recognize whether or not this is type 1 all around or type 2 one side. Show me with your fingers, type 1 or type 2. This is important because if you don't recognize which one it is, there's no way you're going to get this right. Kyle, what do you think? Type 2. How many people agree? I can see. Yeah, most of you. This is exactly right. This is type 2. This is one side. How do you know, Kyle, that this is not type 2? It says length is increased by 2. Yeah, it doesn't say anywhere in this problem where it is increased by 4 all around or anything like that. Does it? Do you see what I'm talking about here? Okay, go ahead and draw the picture and declare your variables. And show me how it could, the length this time is decreased, isn't it? Okay, so it's a little bit different. But like I said, does the formula change? No. It's total area is equal to area 1 plus area 2. Okay, go ahead, everybody try. So, how many people got this picture? Raise your hand. Okay, we had W and 2W. Now, the red is the decreased area. Does that make sense? So, how many people agree that this is 2W minus 4 and W minus 2 for the length and width for the smaller rectangle, right? We don't do it twice, right? It's just once. Yes, question?
Like, isn't it the length is decreased by 4? Yeah, it says if it's like
Yeah, so my length is 2W because it said let W be the width and 2W is the... Oh, did I mess up?
No, you didn't.
Look, it says, let's read it. The length is decreased by 4. Yeah, so it's right, right? My length 2w is decreased by 4, so 2w minus 4.
But it's decreased by 2.
No?
That's width.
This is my length right here. Width is decreased by 2. W minus 2. Right?
Okay.
Right? So here's my width, W, and then that's decreased by 2. W minus 2. My length is 2W, so length is decreased by 4. Is that okay? Are we good? Alright, so then, of course, again, by the way, isn't this always same? Total area is equal to what? Area 1 plus area 2, right? So somebody tell me the equation. What's the total area for the first one? Yes, Nor?
Wait, what first one?
The total area. 2W times W is length times width, right? What about the smaller rectangle? Who can tell me the area equals to now? Smaller rectangle is? Eric, what's the area of the smaller rectangle?
2w minus 4 times w minus 2.
Good. 2W minus 4 right here, right? Times W minus 2. What about this reflection of that L shape? What's the area of that one? Didn't they tell us what it is again? Thankfully they do. What is it? Addison? 24. Isn't that right? That's important. If you didn't know that, you can't do this problem, right? They tell us the area decrease was 24 meters squared. So your equation should be this way. Yes?
Was that negative 24?
Why?
It says decrease by. Yeah.
But I'm always adding these areas. Right? I'm adding the smaller rectangle plus the L shape. If you were to subtract from total area, the 24, then yeah, you would get the smaller rectangle. But do I like adding or do I like subtracting? Adding. Always want to add. Does that make sense, Noah?
Yes.
So you could do it the other way, just like Dominic was saying the other way. But you know, do you see how this? If I keep it this way, it's always same. The formula, total area is going to be smaller area plus the other smaller area, right? Area 1 plus area 2. Don't put minus 24 here, right? Because right, you guys understand what I'm trying to say? Yes. Always add these small areas so that it equals to the big one. It's easier that way. I'm telling you. Is that okay? Go ahead. Everybody try to solve. I'll wait. All right, so somebody tell me what I get when I multiply for the total area. What do I get here? 2W times W is, class? W squared. And then did you guys do this? 2W times W plus. By the way, I changed everything to addition because I don't want to make silly mistakes. 2W times W plus 2W times negative 2 plus negative 4 times W plus negative 4 times negative 2 plus 24, right? Somebody tell me what I get when I multiply those two binomials. How about Cole?
You get 2w squared
Uh-huh.
plus negative 4w
Good.
plus negative 4w
Good.
plus 8
Good.
plus 24.
Right. Plus 24. Don't forget plus 24, right? Because that's that L shape, you know. So then when you add it together, okay, notice I get 2w squared is equal to 2w squared. Negative 4w plus negative 4w, of course, is negative 8w. Plus 32. 8 plus 24 is 32. Look what happens when I subtract w squared from both sides, guys. What do I get on the left side? 0. Can I just leave it blank? No, that'd be wrong. 0 is a number. It's not 10, it's not 5, it's 0. So you need to write that down. Okay, now how do I solve for w? Yes, Stephanie? You add 8w. Guys, remember we had something like this on our test, remember? And some of you didn't know what to do when you was 0. It's just 0 is 0, okay? It's a number. You need to put that in there. Okay, so you add, I could add negative 32, or I would have added 8w, you're right. And of course, the answer comes out to be what, class? 4, right? And what about the length? Again, this time length is again twice as much width, so isn't it 4 by 8? Does that make sense, guys? Do you see how it doesn't matter whether we're increasing or decreasing the size? The formula stays the same, right? The total area is equal to sum of those two smaller area. Does that make sense? Any questions? Can you do something like this for your homework tonight? Okay? Good.